Welcome back to another episode of the Additive Snack podcast. I'm your host, Fabian Alefeld, and today we're joined by a very special guest, Pieter Ruijssenaars. Pieter is the CEO and founder of a company called DiManEx, and DiManEx is really redefining the additive manufacturing supply chain network. Therefore, in today's episode, we'll uncover how additive manufacturing navigates the complexities of supply chains, especially in the light of current geopolitical tensions, especially in the Middle East. We'll also discuss the concept of what Pieter calls, and I love that term, dumb parts. And we'll talk about their significance for additive manufacturing, for its growth, and also how DiManEx is building digital inventories for their clients. So without further ado, let's get going. Pieter, welcome to the show.
Thank you very much, Fabian. Pleasure being here. Looking forward to your questions.
Yeah, I'm looking forward to your answers and our discussions. Let's start easy. What is DiManEx?
DiManEx is a platform-based managed service that helps customers convert their, traditional physical supply chain into more digital supply chains. And the overarching goal is to reduce waste in those supply chains and make them less vulnerable. We'll elaborate on that topic a little bit later. And the overarching goal of DiManEx that what we started with was to do more with less in supply chains. And that relates to a number of topics, but that's the motto of what we founded DiManEx on.
Okay. And you bring up a really good point, which is supply chain agility, complexity, waste reduction. And this is not a new topic that we've talked about ever since COVID, especially supply chain disruptions have been on top of the line. And even a few months ago with the attacks by the Houthis in the Red Sea, we did have, again, the topic of supply chain resilience in everybody's minds. I just read that Maersk, which is one of the largest shipping and supply chain companies, they've avoided the Red Sea since January. Yeah. And they'll expect to continue to avoid the Red Sea throughout the second half of 2024. So we'll continue to see these disruptions. And as soon as we have one figured out, the next one is haunting us. And we're still managing the whiplash effects of COVID, right? So right. I think one of the main questions that everybody with an additive, at least, is asking themselves is, how can additive help us to build more resilient supply chains, not just to react to the current situation, but to truly build them a bit more resiliently? What's your take on that, and what's your point of view?
I think the supply chains have been affected over the last 3 or 4 years, but will continue to be affected over the next 5 to 10 years by geopolitical stress or even environmental problems like natural disasters. They will all have a negative impact on supply chains. As long as supply chains are based on physical movements of goods from A to B, you'll be vulnerable to these kinds of impacts. And that needs to change, and it can change, actually. You can change towards a more proactive approach towards these kinds of impacts by making your supply chain more digital. And that can be done by, for instance, creating digital twins of your part. Instead of producing it in large quantities centrally somewhere in perhaps China and then transport it across the globe to the various locations where you need it, you can have a digital library of validated parts that you can actually print on demand, on location, in the quantity, with the right quality. And that avoids the transportation, and it avoids the reliance on certain routes of trafficking to get the parts to one place or another. So there's multiple ways where AM and digitization, is a bit of a combination, the two can help out. It makes you less vulnerable, less time, and less cost involved in doing so. But we see that too little happening. And what we've seen, and it's funny, for the last 3-4 years with the start of COVID, that companies realized we need to do this differently. Unfortunately, over the last 1 or 2 years, when the dust had settled down after COVID, companies still resort to the traditional ways of applying their supply chain and moving goods from A to B. But I think there will be, and we'll elaborate on that and later on in this conversation, there will be other influences that will drive that forward, like legislation. If you look at legislation with regard to sustainability, that will force companies to change. if not the economic reasons of their supply chain being impacted.
Yeah, it's a really good point. I also realized that, and I haven't lived in Europe for a number of years now, but especially in North America, the talk about reshoring, nearshoring, bringing manufacturing back to at least the North American continent is definitely on top of people's minds. Not only to improve supply chain resilience, but also to build back up workforce that has been lost since the starting of the 80s.
Yep.
Do you see a similar trend also in Europe,
Yep.
where people are talking about bringing manufacturing back to Europe?
Yep. Bringing manufacturing back to Europe is one element of avoiding these problems in the supply chain by centralizing it in Asia in terms of production. That's certainly one element to it. And I would say that AM in that sense contributes to the local economies as well here in Europe, where you need the people to operate the machines to have the parts printed. So when you maybe 40, 50 years saw the export of that kind of work towards other areas, now it's going to be reshored here in Europe. And that will drive the economy even further, help the economy here in Europe as well. So that's another indirect effect of AM producing locally where your parts needed, apart from the direct effects, obviously, of lead time reduction, cost reduction, and CO2 emission reduction because you have less transport.
Totally agree. If we see additive parts in the media, on social media, and oftentimes even on demo desks of OEMs, they're typically these almost artistic applications that we see that not every time have an actual purpose to an end user. And you've, for a while now, been shouting from the top of your roof in the Netherlands, look at dumb parts. Can you explain to me what dumb parts are from your perspective, why they are so valuable for organizations, and why there's a strategic focus on those at DiManEx?
Yeah, I definitely have to clarify what I mean with dumb parts. Otherwise, there's going to be a lot of people who are going to be offended. But I think there was a need 10 years ago to look at some exotic parts or specialty parts with the purpose of demonstrating that AM can bring the quality and the result that comes along with the part. But the purpose for that was clearly on demonstrating the value and the quality of a new technology. I think that we're in the current phase where we're looking at the application of such an innovation like AM and where the business benefit of it is. And as I mentioned, we're focusing on supply chains, because that's a huge domain with a huge problem where AM can definitely bring benefit or value. So what I mean with dumb parts in that context is that where some companies would like or tend to look at more exotic parts in their portfolio to have them printed, the only thing you're doing then is that you can demonstrate they can be printed and they can be used. But that's not the goal in itself. The goal is to improve your supply chain performance, reduce lead times, reduce cost, OPEX, reduce capital expenditure in parts that you put on the shelf, reduce the emission of CO2, reduce the material usage and that kind of stuff to improve the supply chain performance, service your customers better in a more efficient way. And for a lot of companies, it is a challenge to start with AM because it's new. And that's what I mean with dumb parts, or rather simple parts. Start with the simple parts in your portfolio of the machines or trains, whatever you sell, that you can easily print, but that immediately solve a problem in your supply chain, be that availability, lead time, or cost, or whatever. Because then you're definitely showing you're solving a problem in the supply chain. Again, AM printing of a part is a means to an end. The end is the solution of a problem in your supply chain. And it's not to demonstrate that you can actually print a part, how sexy it might be. So that's why we always advocate with new customers, keep it simple. Start with the simple parts. 20% of your, what I always call dumb parts, represent 80% of your headache in a supply chain. Focus on these. Now, there's another reason. AM is still fairly new with a lot of companies. So the sooner you get into showcases in terms of problems resolved that everybody can relate to, this is what we've done. We immediately solved the problem in terms of cost or availability. Everyone becomes enthusiastic. And with these showcases, it's far more easy to get a lot of other domains in your organization, like engineering or finance or purchasing, gathered behind the project of AM to drive it further and scale it. The other way around, is not the right approach. Start simple, showcase the successes, and from there on you build trust. And on top of that trust, you can do much more. And gradually you'll move into the domains of the more sexy, critical, or exotic parts.
Hmm. That makes total sense to me. And I think it's definitely an angle that is missed oftentimes at organizations that look into additive. There's certainly a space for high performance applications, right? One of the largest growth drivers of the metal AM industry really is the space industry. And they're truly diving down into all the benefits of additive manufacturing when it comes to design, lightweighting, and high performance thrust chambers or turbo components. But the supply chain performance aspect that you're talking about is equally, if not more impactful for the industry. And last week, I went to the AMS, to the Additive Manufacturing Strategies Conference. There were a bunch of talks, one by Greg Hayes, and he talked about interchangeability. Being able to rapidly design and develop an application, printing that application to a certain threshold, and then flipping over to conventional manufacturing for mass-produced applications, and then ramping down again, especially in the aftermarket through additive manufacturing and a more agile supply chain. And I think that concept combined with your point of view of simple parts, I think makes a lot of sense to me and is overlooked in my opinion.
Yep, I agree.
Nevertheless, it's easier said than done. Can you take me through a project that you guys have done that you can talk about where you started with an organization, really helped them to identify these simpler parts and help them to really prove the supply chain benefits and really business case of additive manufacturing in the supply chain space?
Yep. So you're basically talking about the journey of how we help customers getting from A to Z and adopting AM and scaling it. I'd say that almost every customer that we talk to and start with, we do two things from the start. And I'd like to call it bottom up and top down. Bottom up is, let's identify physically a couple of parts. Where's your biggest problem? Let's see if we can get them printed, show them the result in maybe 2 weeks. We've done it and printed. We solve the problem. Everybody becomes enthusiastic and we'll rally more people for the project and get them involved, and they'll identify more parts, etc., etc. In parallel, we'll do a top-down analysis, and that's data-based and analytics on the potential, the bigger potential. Because the majority of the customers we serve have between 750,000 up to 20 million SKUs, and a part of that can be printed. And in order for an organization to allocate resources, time, and money to the adoption and scaling of AM, you need to know the bigger potential. And that the first few cases bottom up is to build trust. Great quality, looks good. We've done it in 2 weeks. Great. Can we have another couple of parts? Yeah, sure. Everybody becomes enthusiastic. Maybe let's do the top-down thing in parallel. There's a huge potential, not just on a technical assessment on whether or not they can be printed, but the business case we define as well. How much time, costs, or capital is saved if you print the parts when you need them, in the quantity you need them, and at the location you need them, rather than in the old way with a high MOQ, putting it on the shelf. And that makes the C-level usually at customers very eager to adopt AM and scale it. Now that's the start, and that gets them going. After that, it's basically a journey. After that identification of potential and the bottom-up cases to build a couple of successes, it all comes down to people and processes. Equal with regard to knowledge and education on AM. How can I apply it? How do I validate a part? But also processes, so that there should be processes in place to validate printed parts or to have a part redesigned for AM. Need to have skillful people, but also the process to validate that and the right software to, for instance, do simulation and that kind of stuff. Only then will you gradually get to the phase where they can adopt programs. So we run with some of our customers cost reduction programs. Identify parts that are eligible for redesign, make them in a different structure, for instance, hollow, which would cut cost in production for the remaining service lifetime of the part. So you can calculate, so the one-off cost for the redesign is XYZ, which is a fraction of the cost saving for the remaining service lifetime of the part. So these programs, like these cost reduction programs, and there are other types of programs, can only be done if you go through the first 2 phases of learning with it. What does it mean for our people and processes? and then get those in place to be able to run these kinds of programs. And this is a journey that takes, depending on the customer and the industry a little bit, maybe 1 to 2 years to get there. And sorry to interrupt you, but there's no quick route to that cost reduction program, as an example, because that can significantly save you money, but you need to go through that learning phase at the beginning to actually get there and understand it. And that's what companies need to invest in.
If you tell me 1 to 2 years, I'd say that's fast. I think
probably more what I hope.
It's certainly
more what I hope than reality.
Yeah. It's a transformational process, right? Where you need to get a lot of people on board, not just a few key engineers, but supply chain managers, purchasing,
Exactly.
et cetera. And building up that library is certainly a challenge. Is there a company you're able to talk about that has gone through that process?
Yep.
And can you give us a few numbers on how many parts have they identified? What are some of the savings? Whatever you can share.
So actually naming the name of the customer, it's one of our bigger customers in the packaging industry who actually went through that exact process that I just described, from bottom up, starting with a couple of parts, top down analysis, and then educating people. We've trained about, I would say, 200 something engineers on generic awareness for AM, but also design for AM. So they can actually work on their own parts and start from scratch with new products and the machines they build, but also redesign existing parts, but also train their validation processes. So those are companies that, as an example, that run cost reduction programs on between 500 to 1,000 parts. And that doesn't seem a lot, but if you can imagine that one of those parts could save you for the service lifetime somewhere between 15K to 200K for one single part, you can imagine what that does. And the majority of our customers in that process, if they do the top-down analysis, they come up initially with 100,000 to 250,000 SKUs, provide us with a lot of data points from their ERP, PLM, PDM systems that we analyze and tell them what is technically printable and what the potential is for saving in terms of time and money. We'll also files and PDFs, but the journey I described, that's typical for that packaging industry customer that went through that cycle. And now they're embedding it in their processes for engineering and servicing. So servicing their market and their customers, and engineering with regard to product development and product maintenance for the machines they sell.
Those are big numbers. Yeah, super impactful. And I'm sure this is just the beginning, right? If we listen to, for example, the Deutsche Bahn, which is the German railway organization, their point of view is that roughly 10% of their trains components are printable and actually should be printable for interchangeability and reducing supply chain risk. So I'm sure that this client of yours is also just at the beginning of that journey of true savings and true impact of AM on that digital warehouse.
Fully agree. And the great thing about it is they're building an infrastructure, or I always call it a highway with us now, where they have the people, the knowledge, and the processes in our platform to work on it. With the development of AM industry, with new materials, new technologies coming along, between to 20% printable now, different customers, different industries, but on average, will only increase. But your highway is there. So with new technologies and new materials coming about, you'll be able to stack more cars on that highway because that is in place. You've got the knowledge, you've got the infrastructure, you got the software to be able to scale it, and just waiting for new technologies and materials to come along. So that 8 to 20% will increase to 25, 30%. And one key element in that, and I think we'll get into that later on in the discussion, is what we like to call change management. The adoption and scaling of AM and the speed with which that happens has to do with people and what's in between their ears. And as long as we all in the AM industry keep calling it, this is a 3D printed part, or an OEM tells that to their customer, they're always going to look at it, that's weird, a 3D printed part, need to look at it. If we stop doing that, the 8 to 20, 25% of the parts printable will get the same place as traditional manufactured parts in that supply chain, in that value chain. And the sooner we do that, the faster the uptake will be, the less questions will be asked, and we can all speed it up to the benefit of the customers that apply AM.
That's a really good point. I recently stumbled across a website of a supplier to the consumer industry, and they know they have additive systems. And on their website, which is targeted to some of the larger consumer brands, there's no mentioning of additive.
No.
There's only mentioning of 10x faster time to market, fast iterability with them, and really allowing these larger brands to test out new consumer products without having to invest into tooling and long lead times, right? So that's a really good point that you're making. Let's not even talk about additive itself. Let's talk about the applications
and benefits. Yeah, fully agree.
Yeah, you mentioned sustainability a lot. Let's talk about that for a second. What is interesting about DiManEx from my perspective is that you guys aren't really a software company that helps organizations identify parts. You're a supplier, really. You're a supplier of parts, and you have a network of suppliers that you leverage in order to really take these parts that are identified all the way to the warehouse, to the customer. With that understanding of the full supply chain, what role does sustainability play in that space?
Let's get back at the beginning of this conversation. I said that the start of DiManEx was all about to do more with less. And this is what AM and digitization and certainly data and analytics can bring. So we're doing two things, the analytical data side as well as the fulfillment side. And the latter we needed to do because the market wasn't that ready. If we would have provided only data and analytics about 8 years ago, customers would say, great, I got the insight. And now, where do I start? Where do I print it? So he needed to bring the full, or what we call managed service end to end, and we take that responsibility, no problem. But there will be a time over the next couple of years where some customers will be doing that themselves, locally on-prem with their printers, or there will be larger aggregators in terms of placing orders to print parts. So it all comes down to the business insights, the analytics at the forefront. And I'll get back to your point on sustainability. Our analytics looks at whether or not parts are printable or not technically and what the economic benefit of it is, as well as the design for AM eligibility. Are they eligible to have them redesigned? Because if you do, you can cut costs, make it stronger, make it more sustainable in the production, etc. And the third pillar of analysis is sustainability. What is the effect if you would print the part in the amount you need them at the location and the time you need it? And if you would use a more circular material in the redesigned part, what is the sustainability benefit? And for this sustainability, we use ourselves and in the conversation with our customers, the R ladder. Not sure if you're familiar with that, but it starts with a lot of R's like rethink, refuse, reuse, reman, and a couple of more of these R's. And our services contribute to that. Let me give you an example on rethink. That's where analytics comes in. So customers now buy an MOQ because they need the part, buy 2,000, stock it, and take off the shelf as they need it. Rethink before you do that. Run analysis. Okay, looking at the average demand over the last 3 years, which is far less usually than the MOQ. Why not print the part in the quantity you need instead of buying the MOQ? And by doing that, you avoid the production of parts that are going to be on the shelf, and part of it will always be scrapped because they're never going to be used. So rethink is the first pillar on that R ladder. And for that, you need analytics, analysis based on data. The next one is to refuse an MOQ. Don't buy an MOQ. I'll give you an example of in the railway industry. Don't buy an MOQ because you're forced by your supplier. If you can print the part, print what you need. About 5 years ago, we advised one of our railway customers in their contracts for their OEM train manufacturers to put in an article, gave them the opportunity and the right to use the design for a part to have it printed to keep the train running. That train customer waits sometimes about 120 to 220 days to get a part. So for service purposes, to keep the trains rolling, which our government holds them accountable for, they acknowledge the right and put in an article for the new tender of a train to have that right and use that design. That is to refuse the MOQ of a supplier of your machine, train, or whatever. And that's another way how we can contribute to that sustainability thing by having part printed that you and identified that you can print.
I have the assumption that if you find a positive business case for additive, there's a really high chance that you also have a positive business case for sustainability, purely due to the fact that ultimately you're saving resources either on material, on energy, or on waste.
Correct.
And therefore, you're also contributing to a more resourceful management of your supply chain. Is that a correct assumption?
Yeah, but it's a limited assumption, with all due respect to you, dear Fabian. And that is the fact that if you would
No.
redesign the part with AM in mind and make it lighter, you have the indirect effect that the conveyor belt requires less energy to keep the grippers rolling around and fill the bottles. And that is a result of using design for AM to make the part lighter and stronger, etc., to have it where you have to use less energy to keep the conveyor belt running. Another example there is that because it's stronger and lighter, normally grippers in this particular case of our customer needed to be replaced 3 times a year, but now it's once in 2 years. That saves you time and cost of maintenance people to go to the machine, have it stand still, replace the grippers 3 times a year instead of once in 2 years. So there's a lot more cost related, but also sustainability related. I think that with design for AM, possibly for one of the first times in a long period, cost and sustainability can go hand in hand. If you redesign a part that was a solid block into a hollow structure with similar performance features on the part with AM material and have it printed, not only will you use less material, you also can use, in a number of cases, circular material. So then both the production cost will go down throughout the service lifetime, and you use a circular material. So they can go hand in hand. I think that's one of the tasks for us all in this AM industry is to educate customers on that, because they think AM is expensive. It's not expensive. It doesn't have to be expensive, certainly not from a TCO point of view. And it can go hand in hand with sustainability.
Yeah. But you just made my point, right? If I find a part that has a positive business case, especially from a total cost of ownership perspective, you most likely also are saving carbon emissions by switching over to AM. And even if this initial part, like a gripper, is slightly more expensive, but over the lifetime of it, I'm saving energy on the robotics. I'm saving downtime because of replacements, and at some point I do have to do a tool change. So I have a positive business case, and I also most likely have a sustainability case, which makes this super enticing also for organizations that are trying to push sustainability in their manufacturing and supply chains, etc.
Yeah, but it requires something that you previously mentioned, change management. So you need to want to look at it that way as a company. Because if you look at it isolated from a production cost point of view, you would still say, oh, it's too expensive to print the part. But if you want to see it in the broader perspective, TCO, that you don't have mold costs, stock keeping costs, transport costs, less material cost, etc., then you're doing a great job, and then you're benefiting from it as a company. But that requires also the purchaser to be able to purchase such a part, which is in production cost and given the quantity he buys, more expensive, but all the other benefits should be taken into account as well. I think that in terms of change management, that's one of the things a lot of companies now gradually get towards, that they look at purchasing parts in a supply chain, not from a silo cost reduction potential, but from a TCO potential.
I hear that more and more often, and unfortunately, that is one of the main hurdles, which is understandable, right? We're implementing a new manufacturing technology. We're implementing new supply chain partners, and that is quite challenging for companies. How do you approach that from within your projects?
By starting small and with a problem. By addressing a problem that you can solve fairly easy, whether or not just print the part so you have it, because you can't have it in another way. Redesigning the part, educating the customer on the potential, whatever it may be, you should start with a simple case, a problem that you address. And with AM, there are multiple ways of addressing various problems of the customer, but that's the only way you get people enthusiastic and you build trust. And on top of that trust, you can scale. So don't try to make the customer bite or swallow the whole elephant from the day one. That's not going to work. We tried it as well. Doesn't work. Start small, trust, And funny enough, 8 years ago, I thought, yeah, let's build software and a platform, throw it across the fence, and it flies like a rocket because I see the benefit of AM. Nah, it's about people. It's about people at the customer side, my people, that build trust with those people and the relationship of trust. On top of that, they'll talk to you about, hey, can we do more with design? How does that work? And okay, do we need to educate people? Yeah. Do you have an education program, a competence? Yeah, we have that. Okay, let's start. That's the only way it works. Unfortunately, because it would have been nice if it would have been scalable like that in the first instance, but hey.
Yeah, a lot of people thought to approach additive like a SaaS, like the SaaS industry, right? It's a super scalable technology. It's a digital manufacturing technology, but I think people underestimate what it takes to build machines, reliable machines. And people underestimate what it takes to, like you said, take the people with you.
Yeah.
And especially in days of talks on AI, where there's also overpromise in that space, we most likely lose sight of bringing the people with us to truly show the full potential of the technology. And speaking of people and potential, where do you see the industry going when it comes to supply chain? You have a pretty good grasp on it because you're planting the seeds of these early stage projects where you're starting small, and you probably have a pretty good grasp on who is growing, who is winning. What's your take? How is the industry evolving when it comes to supply chain adoption?
In terms of supply chain adoption of AM, I would say there will be a couple of factors that will influence the adoption and scaling of it. One is legislation. Certainly the example I gave on sustainability, there will be different legislation where greenwashing is over. You need to prove that you contribute in a measurable way, and AM can help do that, and our analytics can help to do that as well. Second, there will be new developments in terms of technology on AM, materials and machines and technologies that will make things easier and faster, etc. Third element is the supply chain geopolitical stuff and problems that will drive customers or global players certainly to do things differently. But also us in the AM industry, stop talking about printed parts. Start talking about we're solving a problem. Regardless how I do it, I'll solve your problem. Fine. That all will help the adoption of it, and sooner or later, and it probably will take longer than we hope it would do, but it will be there. And I'm convinced that in about 10, 15 years, AM will be in a similar stage as other more traditional manufacturing technologies. 25 years ago, people said that with the internet, everything's going to be online, etc. There's a clear hybrid version, different models, different situations, but there's a clear hybrid model between online and offline. It's going to be a hybrid model between additive manufacturing and the other more traditional manufacturing technologies. And some industries and some customers will have it more, others will have it less. Depends on the business, the problems, etc. But there will be a hybrid model, and it will have its place as a solid and future-proof manufacturing technology with everything that comes along with it. That includes the software, the analytics. I think that one differentiator that helps in that domain is data. We notice that as well with customers. Lack of data, completeness of data, reliability data, and any innovation, whether that be AM or predictive analysis or maintenance, rely on data. We help customers aggregate data by extracting that in bulk from PDFs, so they can at least work with that for AM, but also for predictive analysis and maintenance. So the more companies invest in data, AI, and acknowledge that the supply chain in the physical form is not a sustainable one, sustainable from an economic and ecological point of view, the sooner we'll see broader and more adoption of AM in various applications.
That's a really interesting take. Yeah, I hadn't necessarily made that connection, but also the cheaper and the more available tools become that allow companies to digitize their warehouse, which today is oftentimes in still many industries 2D drawings that are oftentimes even on paper. It is very difficult to get one true source of truth on the full part portfolio. So the more we also see just other players that are in conventional manufacturing or in warehouse management, exploring that space and embracing that space and providing solutions that are that are a bit more accessible, we definitely will see an impact on additive as well, I can believe.
Yeah, definitely.
It was a really good conversation, as always.
Thank you.
Peter and I talk once a month, and we have very enlightening conversations. So we said, let's bring it onto the pod. So thank you so much for being on Additive Snack and sharing your insights with us today.
Thank you very much for the opportunity. I really liked it. It's like every month as we speak, no change there. And hopefully it helps. And if anybody else has more questions, they know where to find you or through you, me.
Perfect. And I think one thing I want to highlight as well is what you said, Peter, which is we need to talk about solutions and successes. And that doesn't only include software or solution providers like yourself or OEMs. It also includes users out there, companies that have adopted additive manufacturing. So if you're out there and you have adopted the technology and you haven't spoken about it, please do. If you want to speak about it on this podcast, please reach out. Happy to share your story, because ultimately all of us will benefit from really growing this industry and especially pushing it into supply chain and telling these cases. So if you're out there, please let me know. To our listeners, thank you for tuning into this episode of the Additive Snack podcast. It was a pleasure to also have you with us today. Please subscribe and rate the podcast on your favorite app. It also helps us to reach more people. And I will see you next time.